I'm going to go ahead and do some supplemental notes for 7.1 because quite frankly there's just not enough. There's not enough there. Okay, so this is about how much it's going to take. You just write it on the back. If you write small, you'll be able to do all this on the back. I'll show you whenever I did it by hand, I wasn't able to fit it all in, so you got it because I was writing too large, okay, when I did my rough draft. So you're going to have to write small, or you can write in your notebook. It doesn't matter. Either or is fine, okay? If you feel like you can get it on the back, fine. If not, use it, put it in your notebook. Let's start by drawing out the Bohr model for nitrogen. Do you remember the Bohr model? It's the one where we draw the empty seats and the rows and all that stuff, okay? If we count these, if we skip the middle here, skip the transition metals, okay, and let's just look where nitrogen, which group nitrogen falls in, starting here. 1, 2, skip all of this, 3, 4, and 5. Nitrogen falls into group 5, okay? So let's go ahead and draw out the Bohr model for nitrogen. It's going to look something like this. Let me get situated here. Excuse me. It's going to look something like this. You draw the N symbol. You draw the first row. Remember this? And then you draw the second row. Again, it's in group 5. It's going to have 5 valence electrons, right? But it's got a grand total of how many electrons? 7 total. It's got 7 total, right? It's got 7 total because it's got 7 protons, therefore it's got 7 electrons. So we got to account for all of those. So let's do that. 1, 2. Let's draw in the empty seats here. 2, 3, 4, 5, 6, 7, 8 empty seats, okay? So 2 electrons so far. It's got 7 total. 2, 3, 4, 5, 6, 7. 7 total electrons. Let's count the valence electrons. 1, 2, 3, 4, and 5. 5 valence electrons and 3 empty seats. This gets complicated quickly. And so what we're going to do now is use something called Lewis structures as a shorthand notation for this. And what Lewis structures does is it looks at just these valence electrons, and we abbreviate the valence electrons using dots, because really the 2 electrons in the row before we don't need to worry about because they don't have any function, right? They're filled up. They don't aid in bonding in any way. So we're just going to look at the valence electrons, and we have 1, 2, 3, 4, 5 of them. So let's go ahead and do that. 1, 2, 3, 4, 5. And that's the Lewis structure for nitrogen. Now, there's rules to this. For example, this, you can't just place the electrons wherever you want to. That's not acceptable. That's not okay. And that's not the correct Lewis structure. Okay, so let's go ahead and look at what these rules are. And they're very simple. Okay, so let's go ahead and start with rule number 1. Let me zoom in here if I can. Okay, rule number 1. You write the chemical symbol. In this case, it's going to be N. Go ahead and copy that. Step 1, write the chemical symbol. Step 2, identify which group it's in. N is in group 5. Again, let's count. Group 1, group 2, skip the transition metals. Group 3, group 4, group 5. So go ahead and write that step. Step 3, imagine N has a box around it. N is in group 5. You're going to draw 5 dots. Start at the top and place 1 dot on each side of the box. If there are more than 4 dots, if there, ooh, that's terrible. If there are more than 4 dots, no. Let's just say this. After 4 dots, you can double up. After 4 dots, you can double up. Okay, so let's go ahead and do that. Ready? We're going to write an N again. I'm going to imagine there to be an invisible box around N with 4 sides. And I go 1, 2, 3, 4. Now I can double up and write 5. Here are some notes. The sides that have single dots also have empty seats. Yeah, that's true. Look. See, there's still 3 empty seats. We just don't draw them in on the Lewis structures. We don't draw in the empty seats. They're assumed to be here. They're assumed that there's empty seats here. We don't need to show them anymore. That gets too complicated. Okay, that gets too complicated to show the empty seats. We just have to imagine that they're there. Lewis structures don't work for the transition metals. Yeah, they don't work for transition metals. Okay, so you got 3 dots here. Look, 1, 2, and 3. There's nitrogen. So you can imagine it like that, although these are the empty seats and these represent the electrons. But anyway, they correspond with one another. Okay? Let's go ahead and try to draw the Lewis structures for... Let's try to draw the Lewis structures for everything in this period right here, in period 2. In period 2. Let's draw the Lewis structures for those, and I'm going to do that over here. So starting with lithium is in group 1 and beryllium is in group 2. So let's go with lithium first. I'm going to do lithium, Li. Group 1, 1 valence electron. Beryllium. Give yourself space here. Don't put beryllium right underneath, otherwise you're going to get confused later on. Beryllium is in group 2. I've got 1, 2. Next is boron, carbon, nitrogen. So boron's in group 3. 1, 2, 3. Carbon is in group 4. 1, 2, 3, and 4. Right? Group 3, group 4, group 5, group 6, group 7, group 8. Nitrogen, group 5. Looks like this. 1, 2, 3, 4, and 5. Oxygen, group 6. 1, 2, 3, 4, 5, 6. Fluorine, group 7. 1, 2, 3, 4, 5, 6, 7. Keep these pairs together. Don't do stuff like this. I see this, or I might see something like this. That's not okay, you guys. That will get you, you're not going to get credit if you do that. Okay, that is incorrect. That's not a Lewis structure. Okay, and then last is neon, which is in group 8. Now check it out. Look, neon. 1, 2, 3, 4, 5, 6, 7, 8. No empty seats. Neon doesn't have any empty seats. That means it doesn't have any places to bond, right? That's what these are. These are bonding sites. Neon doesn't have that. Nitrogen has 3 bonding sites. There you go, 1, 2, and 3. So now if you haven't figured it out already, the reason we did this first is so you can get a hands-on for what these molecules look like. But now you have to imagine that this is the representation of the two. This is a 3-dimensional representation of this right here, of this Lewis structure. That's what this is. So the Lewis structure, another way to look at it is the Lewis structure is the 2-dimensional representation of this. So we can actually, now we don't need these models anymore, okay? Now you can figure out what the elements, or rather what the compounds look like on paper. You don't need to take a model and do all that anymore. Although it's helpful and you still can if you want to. But you can now work it out on paper what these molecules are going to look like. I'm going to do that in the next video, 7.1, notes part 1, or part 2 rather.